Hello and welcome to Sudeepa tutorial. This is chapter 1 of grade 9 science, matter in our surroundings, and this is the second module video of the same chapter. In this module, we are going to discuss in details about the solid state, the liquid state and the gaseous state of matter. Before we start, let's have a quick recap of what we have studied in the first module. We have studied that matter is made up of particles or molecules. Particles attract each other with a force. The intensity of force between the particles is maximum in solids, lesser in liquids, and least in gases. Particles are in a state of continuous motion and possess kinetic energy. Kinetic energy increases with rise in temperature. Particles of some form of matter can diffuse with other form of matter. If you have missed the module 1 video of this topic, kindly visit it. I had also provided an assessment in the description box below. Do solve it to prepare yourself and score higher in your school exams. Now let's start. In this discussion, we are going to see the details of the states of matter. So let's start with the solid state first. Let's consider these examples. Let us take a pen, a book, a needle, and a piece of wooden stick. Sketch the shape of the above articles that I mentioned just now in your notebook by moving a pencil around them. Now there are some questions pertaining to these 4 articles that I mentioned just now. Do they change their shape? Of course not. And you are right if you're answering after me. What happens if they are hammered? We have seen in the first module video that when you are trying to hammer a nail, which is stuck to a wooden block, it may either go inside the block or it may bend, right? In this case also, if you hammer a pen or a book, a stick or a needle, it may break, its shape may change, or maybe there is no change in it at all. Do they have a fixed volume? Yes, definitely. The space occupied by a solid, which is called its volume, remains fixed. That is, it does not change. Can you compress them? When we say compress, we mean that on application of force, is there any change? No. Solids do not change even if they are compressed. Do they diffuse? I hope you remember the meaning of the word diffusion. It is the property by which the molecules of 2 different types of matter can mix very easily. In normal condition, the molecules of solid do not mix with one another, but there are some exceptions to this rule. Now that we have discussed about the pen, the stick, the needle and the book, which are solid, let's discuss some other solids as well. When you stretch a rubber band, it changes its shape. Do you still consider it a solid? Because the belief is that solids don't change the shape. Take a second example. Take salt and sugar into containers and see the shape it takes. If it is a cylindrical container, it will take the shape of the cylinder. If it is a cubical container, it will take the shape of the cube. Do you still consider them as solids? Take the third example. Just now we have mentioned that solids cannot be compressed. Take a sponge. Sponge is also a solid. Can it be compressed? Yes, it can be. Do you still consider it a solid? So these are 3 solids, a rubber band, salt and sugar, sponge, which are solids. But there is a twist in the understanding. In my opinion, I will still consider the rubber band, salt, sugar and sponge as solids due to the following reasons. The rubber band changes its shape on application of force, which is temporary, where it reverts back to the original shape once released. The second 2 examples, that is salt and sugar. In this case, you have to consider the individual crystals of sugar and salt, which do not at all change its shape if you keep it in a cylindrical container or you keep it in a cubical container. In case of sponge, it too is a solid. It has holes which traps air. When you compress it, that is when you apply force on it, the air will be released. and hence it can be compressed. Let's take a few more examples from our daily life. The flour particles can be converted into a dough, further rolled out into chapatis. This may confuse you because the flour that you buy from the shop is in the form of a powder and the chapatis have beautiful circular shape. So is it that somewhere we are considering that solids do not change their shape on their own? So in this case, you have to consider the minute particles of flour which are solid and they do not change their shape. In the second case also, a potter creates beautiful artifacts of various designs from the same lump of mud by the application of pressure. Sometimes a tub, sometimes a flour vase. It is also an example of a solid. Now we say that solids do not flow, but in case of the sand watch, there are two compartments, the upper and the lower, and the sand flows freely through this minute opening between the two compartments. This is just a transfer of the sand. It has got nothing to do with the tendency of the gases and the liquids to flow. So the word flow in this case should not confuse you. When you rinse a cloth, you bring a change in the shape of the cloth. But remember, this is a temporary change. It is by the application of pressure, but there is no permanent change in the shape of the cloth on its own. Hence, these confusing examples should not be considered under any type of exception. So let's summarize what we have studied about solids. Solids have definite shape. The solids have a distinct boundary. They have a definite volume. They are least compressible. No diffusion is observed under normal conditions. So this was about solids. Now we proceed to the liquid state. Now let's consider activity 1.10. What happens when 50 milliliter of different liquid, maybe water, milk, cooking oil, juice, cold drink, are stored in containers of various shape? Let us take the second example. Does the volume remain the same if a liquid is transferred to different containers of different capacity and shape? Third example, does the volume of a liquid change when it spills? Now let's see the answers one by one. Liquids take up the shape of the container in which they are stored. They do not have a fixed shape. In the second case, liquid flows freely from one container to the other. However, the quantity or the space occupied by the liquid, that is volume, does not change. And in the third case, when you spill the liquid, its volume still remains the same. So there should be no confusion about its volume. Now let's proceed to another property, which is diffusion. In case of solids, we have seen that under normal conditions, the solids do not diffuse. They do not mix up with one another. But in case of liquid, it is exactly the opposite. Liquids can dissolve other substances. Like for example, you often see when your mother prepares tea, she mixes milk and water. You can mix water and honey, right? You can allow sugar crystals to dissolve in water. So liquids do have a property of diffusion, and that is actually a blessing. Aquatic animals staying underwater can breathe by the help of that property. Liquids dissolve a large number of gases, and hence multiple aquatic organisms can survive. Now let's summarize about the properties of liquids. Liquids do not have a definite shape. It takes the shape of the container in which it is kept. It has got no distinct boundary, therefore, but it has a definite volume, and diffusion is a property that is largely observed in liquids. Now let's proceed to the gaseous state, activity 1.11. This is a very interesting activity that was conducted in which we are trying to prove compressibility, because compressibility has immense use in our daily life. And how it is, I'll talk in a moment. As you can see in the above diagram, 3 syringes are filled with chalk, water and gas. Chalk is a solid, water is a liquid, and in the third, it is a gas. While you fill up these substances in the syringe, you open the piston and then you put the piston back. And look at the image at the bottom now. You are applying same amount of pressure on the 3 pistons of the 3 syringes. When it is the chalk powder, that is the solid, the piston hardly moves. When it is the water, it can slightly move. And when it is the air, that is the third syringe, the piston comes down or gets displaced by a large extent. What does it prove? It simply proves that the chalk powder, that is the solid, has offered the greatest resistance. It did not allow the piston to come down, thereby proving that solids are not so easily compressible. In the second case, water, it is slightly more compressible, while in case of gas, it can be compressed to a large extent. And this property of gases is used in our day-to-day life in the domestic gas cylinders in your house. That is the LPG, liquefied petroleum gas. It is a fuel, as you must be knowing, and you see your mother uses it for cooking. This LPG cylinder contains a flammable mixture of gases. What is flammable? Flammable is something which you can light, that is, you can burn it. That if you hold a matchstick or a lighter, it will get ignited. A large amount of gas can be compressed under pressure and it can be filled inside that cylinder, and it is good enough to last for a month and even more. This is due to the property of compressibility of gases. Also, you must have seen the CNG, that is the compressed natural gas. Most of the vehicles now have the CNG cylinders fitted at the back. You can see here in the image. It is a replacement of the fossil fuel petroleum, and a large amount of it can be filled inside by the property of compressibility. Now, regarding LPG, the first one, LPG is a very risky fuel. And why do I say it risky? Because it can lead to terrible fire in the house or in the building if it is not carefully handled. So, to avoid this kind of explosion and fire, there is a chemical which is added in the liquefied petroleum gas. The smell of the gas is very typical. It has the smell of rotten cabbages. The name of the chemical is ethyl mercaptan. You have to remember this name because this is a lifesaver. So sometimes you may hear your mother telling, is there a gas leak? And she immediately goes to the kitchen and tries to check if there is some leakage. This is what the ethyl mercaptan smell, which is very typical, makes us alert and saves us from accidents. So let's summarize about the properties of gases. Gases do not have definite shape. They do not have distinct boundary. They do not have definite volume. They can occupy any amount of space and they diffuse very fast. We have discussed experiments or activities in our module 1 video in which I had mentioned that if you burn an incense stick or if you spray perfume on your body or maybe a room freshener, you experience the fragrance of the same even if you are not close by. That is because of the property of diffusion. And lastly, the solid molecules you can see are very closely packed. That is, the particles are very closely packed. In case of liquids, there is distance between them, and that distance is called intermolecular space. In case of gases, as you can observe, the distance is too much. And these are the reasons why the states of matter behave differently. The difference in the states of matter based on the properties like volume, diffusion, compressibility, rigidity or fluidity, density, shape, kinetic energy, interparticle space, interparticle force, intermolecular force, and arrangement of the molecules are given for solids, liquids, and gases. This will be of help to you before your examinations. Like, share, and subscribe to Sudeepa tutorial. There are 2 assessments, one from the first module and the other from today's module. Please go through the module twice and solve both the assessments. Thanks a lot for watching.